Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me just turn on my preview screen. Let me just go and see. Okay. Hi Bipin Chandra. Hi Ajay Parmar. Okay, seems like I'm fairly visible as well as equally audible. Let me just lower down the quality of this. Okay. So let's just start. Okay, let me just. Okay. गुड इवनिंग सुशील जी, कैसे हैं आप? सूरज कंजुया, हाय, गुड इवनिंग एवरीवन. टू बाय द वे, हैप्पी रिपब्लिक डे एवरीवन. Okay, fair enough. Today we would be having the most interesting topic, and you would be getting a good hold of this topic if you already are familiar with, just a sec, yeah, if you are already familiar with recursion as well as a little bit terminologies of trees. But basic terminologies of trees would be covered by me, so you don't need to care much about that. But for backtracking, you need to have a good hold over recursion. Okay, so if you're not having a good hold over recursion, so I suggest you. Okay, good evening Ankit Kumar Gupta. Good evening Sampreet Mirlia. Yeah. So let's start with the first problem itself. So last day we discussed a problem that print all permutation of the given string. Okay, print all the permutations of the given string. Then we talked about A, B and C, all the permutations of A, B and C. Now, can you please tell me, the people who already know this question, who already have seen this question, okay, today we would be implementing it live, okay, implementing it live in the session itself. Okay, so may I have a quick reply from the people that who all are already familiar with this question? Fair enough. Now let me give a quick overview of over that. So what we can do is we can just swap the characters. So if A is swapped with itself, it would become A and then B and then C. If A is swapped with B, then it would become B, A and C. If A is swapped with C, this would become C, B and A. Okay. Now what we can do is we can fix the first character because that work is done, and then we can swap B with itself. So if B is swapped with itself, it would become A, B and C. If B is swapped with the next character, it would become A, C and B. If B is swapped with itself, it would become B, A and C. And then if A is swapped with the next character, it would become B, C and A. Now let us do for this also. C would remain at the same position. B would be replaced, swapped with the next character. So this would become C, A, B, and B would remain at that position, that is C, B and A. Now if we fix the last character itself, we have no more characters to swap anything. That's why we can say that this is the available permutations of the given string itself. Okay, now tell me if this thing is clear or not. Okay, I hope this should be clear. By the way, I'm taking so much effort to come at this time, right on time. I'm having my dinner early, I'm making all this setup, and I'm preparing the notes, and I'm doing everything for just free. So I expect your attention and I expect your reply. So if possible, you can do the needful. If not, okay, now a graphical representation of that. So this is the whole graphical representation. This is with the recursion tree. of the permutation of the string ABC, whatever is told at that point of time is told at this point of time also. Okay, so just quickly take a screenshot of this. I expect that you have already took a screenshot of this. Now let's move to the implementation of this particular problem itself. Okay, now let's start with the implementation. So this particular problem can be found at this position, and we can do like this. So we need to provide a vector of string. Sir, are you going for recursion? Yeah, I'm going for recursion. Okay, so basically what would be the process is that, so I would be moving forward with recursion. Then after the swapping is done, I need to swap back again to get the original string itself. Okay, so let me just lower down the quality. Yeah, this is what I need to do. Okay, so what can be done is we can say that I need the size of the string s dot size itself. Okay, this is the size of the string. Then what we can do is we can have a vector of string, and let's name it as v. Okay, and then what we can do is we would call the recursive formula, and then we need to sort this v because we need to return in lexicographical order. Lexicographically sorted order means according to the positioning of the alphabets you need to sort it. So v dot begin to v dot end itself. Okay, so basically last class में जो किया था ना उसी को सिर्फ कंटिन्यू कर रहे हैं. ओके, सो आज को ज़्यादा प्रेशर तो है नहीं हमारे पास, बस कंटिन्यू ही करना है, तो थोड़ा आराम से चिल करके कर सकते हैं. फेयर इनफ. Thanks a lot, Tanujan. Now let's move to the first function itself. Okay, so now the first function, the return type would be void. Why the return type would be void? Because we would be storing our answer in the vector itself, the v vector. Okay, so answer तो v vector के अंदर चला जाएगा ना, तो answer v vector के अंदर चला जाएगा, तो we don't need that external one. So then we need L and then we need R. Okay, L and R we have, then the string itself, the string, and then we have the length. Okay, initially if you don't pass the length it is absolutely fine. Okay, and then what you need to do, okay, you need to pass on the vector itself, vector of string. Okay, and you need to make v. Now if L is equal to R, we would have v dot push back. Okay, we need to v dot push back this particular string, and we need to return from that point itself. Okay, this is what you need to do. See, suppose swap किया आगे बढ़ा, swap किया आगे बढ़ा, swap किया आगे बढ़ा, तो इधर का तो फिक्स होते जा रहा है ना. And when we reach the end of the string, at that point of time we know that a string is being produced, उसको डाल दो v के अंदर. This is what we can do. Now we can run a for loop. So int I is equal to L itself and I is less than R, and then what we can do is I plus plus, and then we would first swap that character. So swap s of L to s of I itself, and then you can again pass on the recursion, but that particular point is now swapped, so we need to move forward and we need to fix this. So what we need to do is L plus 1 comma R comma the same string and the v itself. Okay, and now what we can do is we can just swap back. Okay, swap back मतलब जो damage किया था उसको वापस लो. Okay, मरम पट्टी करो. Fair enough. This is what you need to do. Simple enough. Okay, so let me just maximize this a little bit, or it's clear enough. Okay, so this is done. Now we would call this, so rec of this would be 0 and R would be n minus 1, and this would be the s only and this would be the v only. This can be done, or let's just think that L plus 1. So L plus 1 जब यहाँ पहुँच जाएगा, that means that a string is complete. See, A, B and C, when the L plus 1 would be at that position, this means that I have touched the n. That means we need to just pass the n variable. Okay, fair enough. And let's just check that we have the answer or not. Okay, yes, it's absolutely fine. Okay, So we have a very great output difference. The output difference is hell lot and we are not registering the answer. Okay. So what is the problem here is that we are producing the answer but we are not able to put inside the vector, and even if it is being put, we are not able to get it. Okay. So what can be done in this scenario is that there are two types of pass. Okay. So last time we talked about function. Now we talked about the input return type. The first would be the return type. Let's keep it void. Then we have rec. Okay, then we have suppose int k itself. Okay, so int k. Now that if we edit the k, suppose k is equals to k plus 1. If we edit the k and we just return at this point of time, the output would be what? Quickly tell me the output. Yeah, I would explain you the rec function again. You don't need to worry. Now we are just focusing on two things. What is pass by value and pass by reference. What is the meaning of this? Okay, so pass by value means, I would tell you after I code. Okay, let's just start the coding part, or we can just directly come here, type here Sublime, and this is Sublime text. Let's get this, and this is great. Okay, this is great. We have that simple template, and then we can initialize a is equal to 5, and then we can pass that a to the function itself. Then we can do cout a itself. Okay, fair enough. This is quite simple. And then what we can do is void rec is equals to int a, the same name. Okay, and then a is equals to a plus 1, and then we can just return. So can anyone tell me what would be the output of this? Quickly tell me the output of this, and let us just see the output. The output to this remains the same, that is 5. Now seems like we are making an error, so let's just multiply it with 2 and then let's run it. Okay, so here also the preserving thing is done. Okay, your value is preserved. Okay, so why is this thing happening? This thing is happening because we have a here, and here we are passing a copy of a, and we are editing the copy. Edit the copy. Okay, but at this point we are print the original. We are printing the original. Okay, we are printing the original, but we are passing the copy and editing the value of this copy. That is why we are not getting this value, and this phenomena is known as pass by value. So I can just tell that preserve. Okay, so here the main object is being preserved. What do I mean by pass by reference? Now it might be the scenario that I want to edit this a. Okay, I want the value of a to be changed. Okay, now to change the value of a, I would just simply add a ampersand sign, save it, run it, and then you can see that the value of 5 has been modified and the value of original value of 5 is being the 10. So here we are giving the address of a and original array is modified. Okay, and here we are passing this. That is why the value to this is 10. So we have the edited value, and this phenomena is known as pass by reference. Okay, and we can just write original change. Okay, just write wherever you are making the notes itself. Okay, and I have 15 live viewers at the moment, So can I expect a quick like of 15? Okay, I can expect that. Fair enough. Now let's just see the rec function again. Okay, yeah, fair enough. So let me just remove all of this. Okay, and now we need to pass this array as pass by reference because we want the original vector to be changed. So we would just add this ampersand sign, click on compile and run, and then we would see if this is running or not. And yes, the expected output and our output is absolutely akin. So let's just submit and see if we are getting the correct output or not. And it has successfully passed all the test cases, and this is this. Okay, now I would take a screenshot of this and I would explain you what this is doing. Okay, so initially the value of this, okay, the value of this L is equals to 0 and R is equals to n, okay, R is equals to n, and this S is equal to A, B and C, and the vector initially is empty. So when L is equal to R, we would push back, but now L is not equal to R. So first we would swap L with I itself, and I is from L to less than R. So first we would swap with this, then we would swap with this, then we would swap with this. But after each condition we are passing L plus 1. That is, we are passing 1 and n, then we are passing 2 and then we are passing 3 and n. Now this is L and I itself. Okay, this is L and I. So whatever damage we are doing initially, we are just damaging the whole string, and whatever damage is being done, we are just reverting back the damage itself. Okay, so yeah, okay, yeah, so this is done. By the way, while I'm just explaining, you can just read this question. Task number 1674. 1674. Now let me just explain you what is this all about. So let's remove all of this and let's just start with this. Yeah, this is small, and now we can just swap this value, make it a little bit small, and then we can go here and we can take, okay, fair enough. So this is what we are doing. First we are passing the string as A, B and C. Then we are doing what? L and R itself. Okay, L and R. So L is equal to 0 and R is equal to n, and then we are pushing back the string that we are getting after all of this. Okay, then we are moving forward to the swapping part. Now tell me if this thing is clear or not. Just try to do the dry run from the below image to the top image and top image with the below image. Okay, and let me just start this countdown. Countdown of 1 minute is enough. Just tell me in this time frame that you have understood this or not. Quickly tell me. Okay, quickly tell me this thing is clear or not, or I need to explain you again. Quickly tell me that. Okay, so 1 minute is over. let's move to the next problem. Okay, the next problem states that we are given the structure of a company subordinates, and let's just find subordinates and I would provide the link to you. Okay. And what is the task number? 1674. Okay, let's just be it 167 and 4, and this is the correct one. Let me just paste it. Did you receive the link? Did you receive the link that I have given, or you didn't receive it? Quickly tell me. Are you able to access the link that is provided? Ankit Kumar Gupta, consider talking to me on LinkedIn, and I would just draw it on a pen and paper, and then I would provide you the explanation, and that in that scenario it would be more clear. Okay, so I just want you to read this. Just want you to read this problem, build up an appetite so that we can just read and enjoy the problem for the rest of the time. Okay, so this is the better view of this. Okay, thanks a lot, Vipin Chand. Thanks a lot, Saurav. Just quickly tell me that, just lead the problem, and then I would explain you the basic terminologies of tree, and then we would move to this problem, the explanation of this problem. You would be given the time limit to solve this, and then we would be moving forward. You don't need to worry a lot. Okay, so I think that you have read the problem. Now let's just move to the little bit about trees. Let us learn a little bit about trees, then we would move on to these all topics. Okay, so what is basically a tree? Okay, a tree, suppose a tree has one, let's just see that suppose a tree has 4 nodes. Okay, so just see that the tree is rooted at 1, then 1 is connected to 2, and 1 is connected to 3, and 3 is connected to 4, and 3 is again connected with 5. Okay, so for this we have 1, 2, 3, 4, and 5. Okay, so we can see that the number, okay, so we can see that the number of nodes are 5. Okay, and the number of edges are 5 minus 1, that is 4. Okay, now there are still many interesting properties. So the number of nodes is n, and the number of edges are n minus 1. Okay, now a tree, a given graph is a tree if there is only one path from one node to the other node. Okay, let's just see what are the path. So from 2 to 5 there is only one path that I can use, and then I can just move to 3, and then I can move to this one. Okay, 5, this is 5 itself. Yeah, this is what I can do. Now if it is all connected and it does not have cycles, suppose 1 is connected to 2 and 2 is connected to 3. If like this scenario is produced, then at this point a cycle exists. Okay, a cycle exists, and we can't proceed forward, and we can say that this thing is not a tree because a tree has no cycles. Okay, fair enough. So till this point, am I clear or not? Can I have a quick yes or no from the people that they are viewing? May I have a quick yes or no from the people? Now, these all nodes that are present at the bottom are referred to as leaf of the tree. Leaves. Okay, leaf of the tree. Okay, and a forest is a graph that each connected component is a tree. Each connected component is a tree. Okay, this is what is there, and there a kind of root is being present, where we see that it is the topmost part of the tree, and at this point the tree is propagating itself. Okay, and there are things known as ancestor, parent child relationships. Suppose there is 2 present and we have 1 from it. Okay, so this would be called as the ancestor, and this would be called as the child of it. Okay, and parent child relationship is same as it is in real life. Okay, this is the whole definition of a tree. Please don't confuse it with a graph. So let's just revise again what is a tree. A tree has no cycle. A tree has n node. A tree has n minus 1 edges. The topmost tree, which is having only degree 1 means the number of attached edges, they are known as leaves of the tree. And then there is only one path from one node to the other node. Okay, these all things are there, and if you just understand all of this, then you now know tree. Okay, now let's just understand what is tree itself, and then we would try to solve this problem. To solve this problem, what we can do is we can lower down this, and then we can paste the current question in a new page, and we can align it at the top, and then what we can do is we can take care of the screenshots. Okay, we can take care of input as, okay, we want the constraints too, and what do we need to output. Okay, so this is much enough. Okay, and this is done. Okay, so we are given a structure of a company. So basically a company has a structure that where the HR is the most, where the HR, then the subordinates of them. So given the structure of a company, your task is to calculate for each employee the number of their subordinates. Number of people beneath them are known as subordinates. The first line, so basically this is quite clear, that suppose there is a boss present, then there are different subordinates, then I can see that for this subordinate I have 1 2 3 and 4 present subordinates, and this has 0 subordinates, and this has 2 subordinates, this has 0, this has 1. So basically for this 1 2 3 4, for this is 0, for this is 2 1 2. This is how we can say that these are the number of subordinates. And then we are told that the first line of input contains the number of employees. So all the number of employees would be given at this position, which are numbered from 1 to n. And employee 1 is the general director of the company. So you can think like 1 is the head of the company. Okay, you can think like this. Okay, and then after this there are n minus 1 integers for each employee, 2 3 4 and 5, suppose. Okay, and there is a direct boss in the company. Now let's just check out. So for this we have 1 1 2 and 3. Okay, then for these are the number of employees. Okay, their direct boss in the company, for each employee the direct boss in the company. For 2, the direct boss in the company is 1. For again 2, the direct boss is 1. Okay, this is 1 1 2 3. Yeah, for 2, the direct boss in the company is this. For again 2, the direct boss in the company. Okay, we are doing something wrong. Okay, just let me check. Okay, this is 1 1 2 and 3. So after this there are n minus 1 integers for each employee 2 3 and 4. Okay, so we need to go from 2 3 4 and 5. Okay, so we can say that for 2, this is suppose the general director of the company, and suppose 2's boss is 1, I would just draw 2 beneath it. Then 3's boss is also 1, so let's just draw 3 beneath it. And then for 4's boss is 2, so I can just draw 4. And then for 5, the boss is 3, so I can just draw 5 at this position. Okay, now let us just print the number of subordinates. So for this one, okay, let's not remove it. Okay, for this, yeah, so for this one we have this, we have this, we have this, we have this. Okay, so for 1, the number of subordinates are 4. For 2, the number of subordinates is only 1, that is 4, so 1. Then for 3, the number of subordinates is only 1, that is 5. And we have now 4. We have no subordinates beneath it, so it would be 0. And then for 5, there we are no subordinates beneath it, so the value would be 0 itself. Okay, that is why we can say that it is 4 1 1 0 0. 4 1 1 0 0. This is what we can say. Now tell me, is this question clear to you or not? If this question is not clear to you, I would be more than happy to explain you again. Else I would be just moving forward. Let me just see this one again. So we have a lot of people dropping in. Okay. Okay, Ankit Kumar Gupta understood this. Okay. So let's just start with the implementation of this. Okay. Or just a sec. Okay. So you understood the whole point of the question. Now we would solve this problem using a simple recursion. Okay, so let me just remove this and let me just erase all of this. Okay, fair enough. Now what we can do is we can start from the root itself. Okay, and we can make everything 0 indexed. So if we convert 1 2 and 3 to 0 index, 1 would become 0, 2 would become 1, 3 would become 2. So basically what we are doing, we are subtracting -1 from the whole array. This is what we would do in this also. So what we can do is 0 would be connected to 1 and 0 would be connected to 2 and 1 would be connected to 3 and 2 would be connected with 4 itself. Fair enough. This is what we can do and what we can say. Now we would start from the root itself. From the root, if we start, we go down. We say that we have received 1 and then we would go down and say that yes, 3 is the leaf node. And when it is the leaf node, we can say that you have the value 1. Okay. Now when we would again climb back, we would say that the value that was given from the bottom is 1. Okay, this one. Now 4 When we reach a leaf node, we would assign 1 to it. When we would go back, we would say that the 1 was received from bottom. Okay, and then we would go back here and here. Okay, so from this 1 and 1 we would also add this particular, because see, here it was 0, we added 1, here it was 0, we added 1. So from here it was 1, so we would add 2. From here it is 1, so we would add 2. 2 plus 2 is equals to 4 itself. So we can say that for all the nodes we have got the correct reply of it. Okay, this is how we would perform the whole explanation and the whole code of it. Okay, now let's start implementing, and then I would show you the dry run of it. Listen to competitive programming, and this is done, and this can be at this position. Okay, so let's just do simple. Okay, and then we would take care of int n and c in n, and then what we would do is we would go from 1 to less than n. Okay, go from 1 to less than n. So for loop int I is equals to 1, I is less than n, and I plus plus. So suppose n is equals to 5, this would go 1 2 3 4. So 4 number, this is what we can do, what we need to do. Now we would have int x, then we would see in the value x. Okay, then what we would do is we would do v of x dot push back the current index. Okay, the current index I itself. Okay, then we would have a vector of int of arrays, v of n itself. Okay, and the n is equal to const int n is equal to 2e 10 to the power 5. So const int n is equal to 2 into 1 e5, and this is done. Okay, now we would come down and we would say that int c of capital N. Okay, and the global variables are already 0 by default. Okay, this is what we need to do. Next, we have built the whole array itself. Okay, now we would start the same thing. Okay, just a sec. Yeah, now we would take care of DFS, and then we would take care of the source. When this is all done, we would say that DFS of s is equal to 1, and for the auto of neighbors, for v of s, visit all the neighbors of them, and then DFS of neighbor, as there are no cycles, so we need not to have a visited array or something. We don't need to have it, because all the lower would be not visited and we won't be going back. C of s, the number of subordinates from the neighbors or from the lower point would be added to the source itself, C of ng itself. And then what we can do is we can start the DFS from 0, and then for loop int I is equals to 0, I is less than n, and I plus plus. For loop C out, okay, C out C of I minus 1 with and space. Okay, this is what you need to do. Let's just print this. Okay, so we are making error somewhere. Okay, where are we making an error? So int n c in n for loop. Okay, we are for loop int I is equal to n, and int n c in x. Okay, we are starting the DFS from 0, and C of I minus 1 1 1 2 3. Yeah, it's done. then we have C of n, or should we add just 5? Okay, now C of 5, C of S. Okay, thanks a lot. Just wait a second. I of n. Let us just enclose this in the form of brackets. V of, okay, we are not doing int x, C in x and x minus, because we were doing x minus 1 from, we need to make 1 0 index, so we would need to do x minus minus this. This is what we need to do. So now this should run. Yeah, this is run. So 41100. So let's just submit and see if we are getting a correct output or not, and then we would just talk about the solution. This is sadrasa.cpp, and let's just submit it and see. This is pending, test ready, it's accepted. Fair enough, it got accepted. Let's just view the whole of it. And if we just talk about results, let's just see the result of this. And let's just take a screenshot of this DFS function. By the way, quickly pause at this point of time. If you want any explanation of any line, just let me know, and I would be more than happy to explain you. Okay, that's absolutely fine with me. So let me just take this, let me just refresh the screen. I have a question, sir. Yeah, Anand Prakash Chaudhary, please ask your question. So suppose we have a simple tree, like we have 1, we have 2, and we have 3 itself. So initially DFS is passed with 1. Then we are assigning C of source is equal to 1. So this is where we are 1, 2, and 3. So C of source is assigned as 1. Okay, then we are visiting the neighbors. So then from this we are visiting DFS of 2. Okay, DFS of 2. Now we are again assigning DFS of 2 as 1. Then again and the neighbors of 2 is not there. So this is complete. So we are again coming back. Okay, then we are telling that the bot C of S plus C of neighbors. So for 1 the neighbor was 2, and 2 C of 2, this is C of 2, this would be added. So we would be saying that 1 plus 1, that is equal to, so we can say that we have 1 plus 1 itself. Okay, let me just open the, yeah, so this is where we are, and then we have done this. So this is also done. Now the next neighbor. Okay, so the next neighbor, so the neighbor is done. So 1 plus 1. Now we went to 3. C of 3 is also assigned 1. Okay, then C of 1, C, because S is equal to 1, this is the source itself. C of 1 plus C of 3. C of 1 plus C of 3 would make it 1. Okay, this is how for 1 the value is equal to 3, for 2 the value is equal to 1, for 3 the value is equal to 1. Okay, now but the value required was 1 less. For 1 it should be 2, so it is just 1 minus 1, 1 minus 1, 1 minus 1, and this is what we are doing. Okay, so if you just observe this, Ci minus 1, Ci minus 1, and we are making everything as 0 indexed, and we are starting the DFS from 0 because it is told that it is rooted at 0 itself. Okay, this is what it is. So quickly tell me if this thing is clear or not, or I need to explain you or repeat it again. Quickly tell me. Okay, I need to repeat it again. Okay. Mhm. So we have a tree. Suppose this is 1, this is 2, and this is 3 itself. And this is 1, this is 2, and this is 3. So for first we are giving DFS of 1. Then we are coming to the neighbors, that is 2. So we would say that give the DFS of 2, okay, and C of DFS of 2. So now if we again come to the DFS of 2, then this would become source. Now DFS of 2 is assigned with 1, and 1 is also assigned because the source is already assigned with the value 1 itself. And then DFS of 2 is done. Then it is added to the source itself. Okay, so 1 plus 1, that is 2. Okay, then we come to the next neighbor, which is unvisited because this is already visited. Then this is not visited, so we would just visit it. So this is already visited. C3 would be made 1. Now this is already done. Next we would do is C of 1 plus equal to C of 3, which is equal to 1. So C of 1 plus equal to 1. So 1 becomes 3, 2 becomes 1, and 3 becomes 1. But the value needed was minus 1. That's why for 1 it is 2, for 2 it is 0, for 3 it is again 0. Okay. So now tell me if this thing is clear or not. If this thing is not clear, I would be more than happy to explain you again. But you need to let me know. Okay, just let me know if these things are clear or not. And then we would just drop down, we would chat a little bit, then we would drop down. Okay, most of them has already okay, so we would just wait for the next 1.5 minutes, and then we would just drop this down. Okay, so this is the last call for the people who have not understood. If you want assistance on any chat, I would be more than happy to explain you. Okay, seems like I lost the connection. Okay, so that's it for today. Thank you and have a nice day. If you have just attended on my lecture, and if you think that I'm worthy enough for your feedback, just go to the description. You would find a feedback link, Google form link. Fill that up. It makes me feel a little bit better that I'm making a difference to the society that I live in. Thanks for your support.